Imagine this. The hero's spaceship is ambushed by enemy fighters, lasers blaze across the void, ships explode in spectacular fireballs, and the sound of it all, blasts, booms, and all manner of dramatic noises fills the cosmic battleground. It's thrilling, it's intense, it's scientifically impossible. That's right, folks. Despite what countless sci-fi blockbusters will have you believe, space is a vacuum, a silent, soundless vacuum. There's no air up there to carry those cool explosion sounds or the menacing hum of an approaching spacecraft. So while those pew-pew laser sounds make space battles a lot more exciting, if you're actually there, it will be eerily quiet. Just you, your thoughts, and the silent void. In this video, we will be looking at the myths, movies, especially Hollywood, has taught us about space and space travel, starting with myth number 1, sound in space. In the vast emptiness of space, there's no medium like air or water to carry sound waves. What does this mean? Simply put, no air equals no sound. So if you were hanging out next to that epic space battle we imagined earlier, the only soundtrack would be the silence of the vacuum. You could see the explosions, bright flashes of light, maybe some particles flying around, but the only boom will be the one happening inside your imagination. It's a quiet universe out there, folks, so any astronauts wanting to rock out to their favorite tunes better bring headphones. And now for a bit of show and tell. Let's roll a little movie magic of our own. Picture this. We are going to replay those iconic space battle scenes, but this time we are hitting the mute button. That's right, all the lasers and explosions and dramatic spacecraft entries without a single sound. It might feel a bit like watching fireworks in mute, visually stunning but eerily quiet. This silent film version gives us a peek into the real, soundless experience of space. So keep your eyes peeled and your ears, well, give them a break because they won't be needed here. Myth 2. Explosive fireballs in space. Now let's blast off from the silent realms of space and dive into another blockbuster favorite, the big, bold and blazing explosions. Picture your favorite space opera scene, ships clashing, missiles flying, and then kaboom! A massive fireball lights up the void, complete with flames licking the sides of nearby debris. It looks awesome, doesn't it? But hold on to your space helmets because just like our silent space battles, Hollywood's fiery spectacles are more fiction than fact. In the real universe, without good old oxygen to fuel the flames, those dramatic fireballs will be nothing more than a puff of smoke, if that. Let's unpack why space prefers its explosions on the subtler side. In space, no one can hear you explode, and they might not even see much of an explosion either. Here's the deal. Space is a vacuum, which means there's no oxygen hanging around, and without oxygen, fire is pretty much a no-show. So what will really happen if a spacecraft went kaboom in the cosmos? Instead of the grandiose fireballs and billowing flames we see in the movies, any explosion will be a quick flash of light and a cloud of debris swiftly dispersing into the emptiness. It's more of a silent sparkle than a fiery fury. Next time you see a spacecraft erupt into a ball of flames on screen, just remember, it's Hollywood's way of adding a little extra sizzle to the stars. Myth 3. Gravity and movement in space. Have you ever watched a sci-fi movie where the heroes stride confidently through their spaceship as if they are strolling through a park on Earth? It sure makes for smooth storytelling, but in the anti-gravity world of real space travel, things aren't quite so grounded. In these films, whether they are dodging alien attacks or dancing in a mess hall, everyone seems to forget one teeny tiny detail. There's supposed to be very little, if any, gravity up there. No magical gravity wells or invisible force fields, just the cold, hard truth of zero G. When you are soaring through the cosmos, gravity isn't quite the same steadfast companion it is on Earth. Up in space, astronauts experience what's known as microgravity, which means they float rather than walk. In the genuine NASA approved space experience, astronauts glide and tumble through their modules using handrails and Velcro shoes to keep themselves from floating into a wall or another crew member. No casual walking or jogging down the hallway, instead, it's more about graceful pushes and gentle drifts. You won't be running down a corridor like it's a sprint to the grocery store. Myth 4. Instant freezing or boiling in space. Now, let's turn up the heat, or rather, drop the temperature on another cinematic space spectacle: instant freezing or boiling when exposed to the vacuum of space. It's a favorite go-to for dramatic effect in movies. 1 minute a character's helmet cracks, and the next they're a popsicle or a boiling kettle. Thrilling? Absolutely. Accurate? Not exactly. Here's the scoop. Space itself isn't cold or hot. It's a vacuum, which means there's no air to conduct heat or cold. So if you were to take an unfortunate stroll outside your spacecraft without proper gear, you wouldn't instantly turn into an ice statue or burst into steam. Instead, what happens is a bit more complex and involves things like radiation and your body's own heat conduction processes. It's less of a snap freeze and more of a gradual change depending on your environment. So while the movies might have you believe it's a quick transition, the real science says it's a slow dance with temperature. Myth 5. Fast space travel. Next stop on our cosmic tour: the fast lane of space travel. Ever watched a sci-fi flick where the heroes zip from one star system to another faster than you can see light speed? It's like the universe is just one quick subway ride away, with planets and galaxies as easy to hop between as metro stops. Hollywood loves to put the pedal to the metal, turning space travel into a speedy affair that could make even the fastest Formula One car look like a snail. But are we really just a warp drive away from our next interstellar adventure, or has Hollywood been playing fast and loose with the laws of physics? While Hollywood spaceships dart across galaxies in the time it takes to microwave popcorn, real interstellar travel is more like a cross-country road trip: long, planned, and no shortcuts through wormholes. Here's the down-to-earth scoop. Even with the fastest spacecraft we've built, like NASA's Parker Solar Probe, traveling to even our closest stellar neighbor would take tens of thousands of years. We're talking about a journey that outlasts civilizations, not just the runtime of a movie. So while the idea of hopping from Earth to the outer reaches of the Milky Way by the end of a 2-hour film is a fun fantasy, the scientific reality is that we are still figuring out how to get humans safely to Mars. Space travel isn't just a throttle push away. It involves incredible distances, immense planning, and technology that we are still dreaming up. So next time you see a spaceship zipping through hyperspace, enjoy the ride. But remember, a real space travel takes a little longer than a commercial break. Myth 6. Dense asteroid belts. Hollywood loves a good asteroid belt chase scene. It's chaotic, it's risky, and it's visually stunning. We see our space heroes dodging and weaving through a labyrinth of massive rocks, tumbling chaotically in space. It's a nail-biting, edge-of-your-seat kind of scene that makes you clutch your popcorn for dear life. But is this cosmic obstacle course anything like the real deal? While Hollywood's asteroid belts are jam-packed like a rock concert, the truth is a lot less crowded. If you were piloting a spacecraft through our solar system's very own asteroid belt, instead of constant evasive maneuvers, it will be smooth sailing. Why? Because real asteroid belts are not the tight, twisting minefields we see in cinema. In reality, asteroids are spaced incredibly far apart, with hundreds of thousands of miles between them. The chances of a Hollywood-style dodge and weave through this rocky beast are more fiction than fact. So while the idea of navigating a dense field of space boulders make for great visuals and thrilling plot points, the scientific reality is more like a leisurely stroll through a sparse park. Buckle in, keep your eyes peeled, but you can relax. A collision isn't as imminent as the movies would have you believe. Meet 7. Bright and colorful space. Let's turn up the brightness and dial in the saturation as we drift into another visually spectacular meet, the bright and colorful space vistas we see in movies. Picture it. Our space adventurers are cruising through a nebula as radiant as a neon sign, surrounded by star fields so dense and brilliant it's like flying through Times Square at night. This vibrant portrayal makes every frame of a space movie a masterpiece of color and light. But is the cosmos really putting on this light show, or is it a bit of movie magic, a dash of artistic license to jazz up the cold dark void? Alright, let's dim the light and see what the universe really looks like under its natural lighting. Why Hollywood's depiction of space as a vibrant canvas of cosmic color makes for a visually stunning experience, actual space is a bit more, shall we say, understated in its palette. Space is mostly vast and empty, and while there are indeed beautifully colored nebulae and glittering star clusters, they are not as densely packed or vivid to the naked eye as movies might suggest. Much of what we see in those breathtaking Hubble images is enhanced for scientific study and visual impact, showing light frequencies beyond what our eyes can naturally perceive. So while navigating through real space, expect more subtle shades and a lot of darkness, lots and lots of expansive, profound darkness. The real beauty of space is in its stark, awe-inspiring emptiness, punctuated by occasional distant bursts of celestial artistry. It's less neon light and more a delicate sprinkle of cosmic dust across the infinite dark canvas. Meet 8. Humanoid aliens. In countless Hollywood sagas, the alien beings we meet often look like they could apply for a passport on Earth. 2 eyes, 2 ears, a nose, a mouth, and a penchant for English or whatever the space heroes are speaking. They might be green or blue, have a few extra wrinkles or tentacles, but they still fit in quite nicely with human clothes and chairs. But is this just a casting convenience, or should we expect our interstellar neighbors to share our love for bipedal strolls and casual conversation? The reality, based on what we know from the vast diversity of life just on our own planet, suggests that extraterrestrial beings, if they are out there, probably would be auditioning for human roles anytime soon. Why is that? Well, evolution is a creative director that takes cues from an environment's unique characteristics like gravity, atmosphere, temperature, and chemical makeup. This means that life forms evolving on other worlds could be as varied as anything you've seen in the deepest oceans or the weirdest sci-fi flicks. They might not see with the eyes, might not walk with legs, and they might communicate in ways that don't involve sound at all. So while it's convenient for movies to feature aliens we can chat with over a cup of coffee or whatever they might drink, real interstellar biodiversity is likely to be as widely different from us as it is imaginable. Think less, vast scene from Star Wars, and more, biology hasn't even thought of it yet. The universe, after all, is far more creative than even the best Hollywood effects studio. Meet 9. Earth-like gravity on other planets and moons. Ever notice how in most space films, astronauts land on a new planet and just start walking around as if they are strolling through a park? Whether it's a moon, a planet, or a distant rocky outpost, gravity seems to just be right for a light jog or a dramatic chase scene. This gravity generosity makes for great cinema, allowing characters to move and interact in familiar ways without floating awkwardly or hopping around like lunar astronauts. But how realistic is this depiction when we venture beyond Earth's comfortable gravitational pull? While movies might have us believe that every planet or moon is equipped with a handy Earth standard gravity setting, the real universe plays by its own rules. Each celestial body, from the smallest moon to the largest planet, has its own unique gravitational pull, which can be dramatically different from what we are used to here on the home turf. For instance, if you were to step out onto Mars, you will feel about 38% of Earth's gravity. That's light enough to hop around joyfully, but not so light that you will float away. Meanwhile, on the moon, you will experience only about 70% of Earth's gravity, which is why those Apollo astronauts looked like they were bouncing in slow motion. And let's not even start with the gas giant, where you couldn't even stand at all because, well, they are made of gas. So the next time you see a space explorer in a movie jogging normally on an alien world, take it with a grain of space salt. In reality, we'll be in for a wild ride of high jumps and floaty steps, adapting to a cosmic dance dictated by each new world's gravitational whims. Get ready to recalibrate those space legs. And here we have it. We've rocketed through a galaxy of myths that Hollywood has sprinkled across our screens, uncovering the cosmic truths hidden behind special effects and dramatic storytelling. From the silent void of space, where no explosion can be heard, to extra dense asteroid belts, we've seen just how creative and scientifically cheeky our favorite films can be. If you enjoyed this video, hit the like button and also the subscribe button too. Thank you. See you in the next video.